You might come across this. Here is exactly how to crack it. In the reaction here was given and is actually balanced. The mass of coke containing 80% carbon. Do not forget that coke is actually made up of carbon. So carbon. And here we have this coke is actually made up of 80% carbon. Probably the other 20% are other items in that same coke, but the coke is made up of 20% carbon. Full stop. We'll continue. Required to reduce 0.302 kilogram of pure tin oxide is dash. So the first step here is that we are going to calculate the amount of carbon needed to reduce the tin oxide. According to the equation, we have carbon here and we have tin oxide here. So first we need to make use of this equation and calculate the amount of carbon first that we need to use to reduce the tin oxide before we go further to calculate the percentage of coke actually. So the first step to take is using the balanced equation. Would calculate for the molar mass of tin oxide. And so tin oxide SnO2 SnO2 is actually tin. From here, tin is 119, right? Plus oxygen is 16 times 2. 16 times 2 down here, you get 32 times the number of mole here is 1. So we'll just say 1. 19 plus 32 is 151, and that is actually our molar mass. Next, we'll calculate for the molar mass of carbon. Carbon from the equation is actually 2 carbon, so it becomes 12 in bracket times 2, which would help us arrive at 24. Do not forget the amount of tin oxide given. The mass of tin oxide, mass of SnO2, 0.302 kilogram. Once you're able to outline this, we'll delve straight into the calculation. Making use of Sam's relation, what is actually given times what we want over what we know from what is given. So what was given here is 0.302. What we want is our carbon, so we'll say 24 over what do we know from what is given. What we know from the mass of tin oxide given is actually 151, which is this. So we'd say 151. And so if we plug in our data, it becomes 0.302 times 24, and we arrive at 7.248 over 151, and this becomes divided by 151. The final answer here would be 0.048. So we have 0.048 kilogram. Do not forget. And this is of carbon. Do not forget. So carbon is actually 0.048 kilogram. And lastly, the percentage of coke used as asked from the question. Coke used is 100. Since, please note this, we have coke is actually made up of carbon. So you wouldn't say 80 over 100, rather you say 100 over 80 times. This is because you find coke in carbon and not carbon in coke. Do you get? I'll go again. If you see coke, the items that make up coke is actually carbon, so it becomes 100 over 80, not 80 over 100. So times 0.048, and if you punch this, would arrive at 100 times 0.048 would get 4.8 divided by 80. And so 4.8 divided by 80, and your final answer will be 0.06 kilogram. So the amount of coke used here is actually 0.06 kilogram of coke, which is actually our final answer. Now I'd like us to go back to the options and check if we have that there. And so your correct answer is this: 0.06 kilogram of of coke. Please note, the question says the mass of coke containing 80% carbon. Naturally, coke is actually, we first have carbon, then a type of carbon we have coke. Do you get? So you can't say 80 over 100, rather you say 100 over 80, because the coke is contained in it. Because what would make up coke is actually carbon. You win. Just believe. And do not forget, if you want to solve similar questions to this or have a question, click on the link in the description box.